Hi all, this is Harini. Welcome back to our channel Code with Harini. Today we are going to solve September 5 LeetCode challenge, which is minimum operations to make integer 0. So you will be giving a two integers num1 and num2. So in one operation we can choose a integer I in the range 0 to 60. Okay, and subtract the 2 power I plus num2 from num1, and we have to return the integer denoting the minimum number of operations needed to make num1 equal to 0. So here if you see, they have given num1 equals to 3 and num2 equals to minus 2. So they are telling we can make 3 equal to 0 by following operations, by 3 operations. So first they have chosen I equals to 2. 2 power 2 plus minus 2 gives you 2. So 3 minus 2 gives us 1. Again they are choosing the I equals to 2 and subtracting 2 power 2 plus minus 2. Again it's not like now we have 1, right? 1 minus 2, now you give minus 1. So now minus 1 plus 1 will give you 0, right? So yeah, I equals to 0. 2 power 0 is 2 power 0 1 plus minus 1. So minus 1 minus of minus 1 will gives us plus 1. So minus 1 plus 1 gives you 0. So it can be proven that 3 is the minimum number of operations that we need to perform. So num5, num2, 7. So they have given return minus 1 because it can be proven that it is impossible to make 5 equal to 0 by following the condition 2 power I plus num2. Now just take a look how we are going to approach the solve. These are the two examples that they have given. So here the answer is 3, here answer is minus 1. Okay, now just see. Okay, nums of 1, what we can do, you can do, and you can choose 1 2 till, let's assume this k is the answer. Okay, you will be keep on performing num1 minus, and what you will do to power of whatever the I, either to power of 2 plus or minus 2, that is num. So generally what we can do, this is, we'll take it as I1 I2, and what we will be doing, we will be doing to power of I1 plus num2, that will subtract from num1. Next, if it's not 0, then you will do until you will run till the I equals to k, that is your answer. So here I equals to 3. In some cases I might be 4, I might be 5, or how many numbers that it you can take, right? Yeah. So this by doing this we will get 0 as a result. Now what we are doing, now we are moving this all to the right hand side. Now these all will be plus, right? Minus will become plus plus plus. So now if you see, you have num2 as a common. Okay, so that common we will be taking out. How many nums2 will be there? Here I power k, so k nums2 will be there. So yeah, k star nums2 we have taken separately, and we have separated 2 power I. Now here the complexity lies where is which power you will choose. Okay, so that's why uh, like this we will, now what we have done, now we have chosen moved this to right hand side again. Now nums of 1 minus k star num2 equals to the powers 2 power of k. Whatever the current k, if the k is 1, here it will be 2 to the power of 0. If the k equals to 2, it will be 2 to the power of 1. Now by this we'll know how many operations that we will be. So here it's assume our x is um 13. Okay, this gives you the answer as a 13. Okay, now 13, how will you write? 3 4 2 1, which in the form we will write, this is our 13. Now our bits is 3. So now our k, let's assume our k is 5. Okay, now what all the forms that you will return this? Now our k is 5. 5. So you have to write in a form 2 to the power of, now we will be writing 2 to the power of 2. Now I would have taken I equals to 2 here. Next 2 to the power of 1 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 1. So which means now I have taken k 2 to the power of I. Okay. So here the value is 13. Now it is will be 4 plus, this is 2 to the power of 0. Okay, 4 plus 2, 2, 2 plus, so 4 plus 1. So which is 8 plus 5 gives you 13. Okay. We know what is our minimum k by setting the k equals to 1, 2, 3. When we are able to form the x, we know, okay, we have reached the number of operations, we don't need to further go. So as we have discussed, so what all the things, now initially we'll be setting the k equals to 1. So while true, we have to keep on finding the x. X is nothing but your num1 minus k star num2. Okay, this is our x. Okay, now by having 1k, we are by having the k equals to 1, we have to return the minimum operation, right? So we are taking k equals to 1. So by k equals to 1, we are able to form the 0. That's what we'll be checking. By k equals to 1, we will be able to form the 0 or not. So yeah, if it is both as equal, when it is going subtract, we'll get 0, right? So yeah, now we know one cases, if x is less than k. Okay, then what, while you are computing, while if x is less than k, then we can return -1, because x, let's assume our x is 3 and our k equals to 5. Even if you have power of 0, 2 to the power of 0, 2 to the power of 0 for the 5 times, we can't form the x equals to 3, right? So yeah, that's so by any chance, if we are getting k, we are not able to wouldn't have able to form with k equals to 1, 2, 3 and 4, and we have reached k equals to 5, and now our x equals to 3. By even if you put I as a 0, still our value will be 5, which is, so by increasing k equals to 6 doesn't makes any sense right there. So that's why in that case we'll return -1. So if not, another case will be if x, sorry, if k is greater than or equals to x dot bit count. So x dot bit count, generally what it will do means, so if you see x equals to 13, our bit count is 3. So if the k equals to 3 itself, we can form this number. So that is the minimum operation. So here we can give I equals to 0, 1, 2, anything, right? So when the k comes as a 3, that time itself we would have k is equals to greater than or equals to bit count, right? So now if the k equals to, how will you split 2 to 8, 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 0. Okay, like this, I equals to 3, I equals to 2, I equals to 0 itself can form our x. So yeah, then you can straight away return the k in that case. So because we need a minimum operation. So when our k is exceeding your x dot bit count, then we know, okay, whatever current k is our minimum, we can return. Okay, else, okay, if not, then we'll be adding the k and we'll see the next until it comes. So for sure we will have one answer, right? Yeah. By then, by like this, we know the k value. So if you know the k value, that is the number of the operations, and we can, in our assumption, we are just getting the number of operations via k, and we know this is equal to this. Yeah, by just mathematical computation with manipulation, we achieve this solution. I hope this makes sense. So yeah, the time complexity for this will be log. We can assume that time complexity for this will be order of log of num1, because every time when we are decreasing the num1 by based on the k and num2, so for sure it will run half of the num1 times, and once if the x goes less than k, then we are returning. If not, we'll be returning k. So as nums1 decreases monotonically, k increases. Yeah, space complexities or rough one, because we are not using anything except two variables. Yeah, I hope this makes sense to you guys. I guys would have understood how we have derivated the formula and how we are using it to achieve this. Yeah, if you have any questions or concern, please do leave a comment. I'll be happy to help. Yeah, I'll be providing the GitHub link for the solution. You can go and check it out, and you can debug it on your own to have a better clarity. If you like my video, please do like, subscribe and share it with your friends. That will highly motivate me to do more videos daily. Yep, thanks for watching.